we're going to do a thing, introduction to composite transformations. We're going to start with looking at right here, we've got our shape, and we're going to do a composite. I am going to create a line. My line is going to be y equals negative x, and I'm going to change this color so it's easier to see. And we're going to call this y equals negative x. And we know this is the y-axis right here, but it's also x equals 0, just to be clear. So we're going to reflect this thing twice. So we're going to be performing a transformation here. We're going to do a reflection. We're going to choose to reflect it over y equals 0 first. And we're going to choose the shape we're going to apply. So it's reflected over that. Now we're going to do another reflection, except I'm going to reflect it over this line. I'm going to apply this shape to it. So I've reflected it there twice. And I'm just going to use one of the points as an example. I am going to look at these points. So I've reflected this over y equals, x equals 0, excuse me. And right here, this is my A prime. I've reflected it one time, so that's why it's prime. And its point is negative 3, 2. And we can use our rules that we know about that to get there. Now this right here, this point is A double prime. And I got negative 2, 3 for my answer. So we are going to look at using it as an example. We went from here to here to here, and like kind of how we do that. So I'm going to go back to here. I'm going to not use the biggest font I've ever had. And I know that I have A was, I'm going to just keep flipping back and forth to see it, 3, 2. Reflecting, we're just going to write in words first, and then we're going to change it over. Reflecting over x equals 0, y axis. And then we get A prime, which is negative 3, 2. Now we're going to take this point, reflect it over y equals negative x, and we get A double prime is negative 3, 2. A double prime is negative 3, 2. Okay? We reflected the first one. We didn't go back to the original, but we reflected the second one. So we're just going to talk a little bit about what's happening here and the other ways to write it. So when we do this, we kind of write it from the inside out. What we want to do first, what we want to do second. It's kind of in an order that we wouldn't think of it. First, we are doing a reflection, that's little r, of x equals 0. And we do a subscript, which I don't even know if I can do it on here. So this is a subscript, x equals 0. It should be smaller and below. I know I can do squared, right? So I should be able to do subscript. Oh well, it's not worth my time. Of 3, 2. Now, we kind of use this little not symbol or like a little 0 or O. It should be like a lowercase o, except I want you to lowercase, so please don't do that. And we think of that word as following, that little O as following, because the second thing we're going to do is reflection. of, now this is subscript y equals negative x of that same point, okay? So we're doing both of these of this. So we can put these in parentheses. So again, I want to talk about a little bit about that. This means right here. This means following. We can also think of it as parentheses. We're going to do the inside parentheses first before we do the outside. So we've got to think of it that way is what we're doing. Inside, out. So, okay, without looking at what we did before, we could do the same thing with another point. So if we're doing the same thing, if we're going reflection of y equals negative x, and we do that little O as an of, and little r subscript x equals 0, and we wanted to do this with a different point, such as, I don't know, 2, 0. Let's say that. What would happen to it? Okay, well, we know when we reflect over x equals 0, we change the first thing. So the first thing we're doing, instead of 3, 2, it became negative 3, 2. So it would become first negative 2, 0. Remember, I'm doing that reflection of x equals 0 first. So the next thing we're going to do is reflection of y equals negative x would happen next, okay? And that would be, if we do y equals negative x, we are, oh, this is not the right answer. This is not negative 3, 2 here. This is negative 2, 3. So it would change. We would change the signs, and we would flip it. So we would end up with 0, 2 as our answer here. So that's a little bit complicated, but it's kind of the way that we're thinking about doing these for setting it up with that. We'll talk more about that in the future. I do want to emphasize that composite transformations are simply a set of transformations done one after another to a point or a set of points like a shape. Any set of 2 or more transformations performed on a point or a set of points or shape is considered to be a composite transformation. So if I'm doing more than one. So in this case, I did a reflection twice, but you could do a translation, and then a reflection, or a rotation and then a reflection. And we could get to there.